Today we are going to solve LeetCode 35, search insert position. Given a sorted array of distinct integers and the target value, return the index if the target is found. If not, return the index where it could be. If it were inserted in order, you must write an algorithm with big O log n runtime complexity. So before going to solve, you must know basics of arrays and same algorithm we are going to use. Since he mentioned we need to solve in big O of log n and the arrays in sorted order, as I previously mentioned in my previous video. And so what's the first most thought that comes to your mind while seeing this problem? uh, whenever he asks he gives a sorted array and big O of log n, that means we need to solve that problem in the big using binary search. So let's solve this question normally. What's the brute force approach? Simply, like, he's asking if the target is found in the array, we need to return the index. If not, return the index where it should be inserted it. So like, let's take an for loop and iterate from here, like from 0 to end of the array, and see whether the 5 is there or not. If there, return the index. If here the target is stored, so we will check from here to and the entire array. If 2 is there, we will return the index. Otherwise, we will return the index of 2, which is greater than 2. Like here in this case 3. And we will at the then we will break the for loop. So like here I returned the entire thing which I have explained. You can see. Okay. But he asked us to solve in big O of log n. But if we solve using this for loop method, it will be big O of n complexity, which is not suitable, and it is just a brute force approach. We need to solve this in optimal way, and the optimal way is binary search. So let's solve using binary search. Before going to solve this problem, first let's understand like how we will be finding the position that we need to insert in the array. So like, let's take an example array like a is equal to 1 2 3 7 10 22, and the target is 11. And let's imagine like where you will be inserting in this array if the 11 is given to you. So obviously we will be inserting in 0 1 2 3 4 5 fifth position in the place of 22. So as we all know that the binary search means we will keep a start and end, and we will iterate until s is greater than e. So like until this condition violates, we will be executing this. So what as I explained in the previous video, the binary search, what does it do? It just divides the array into two parts. It checks whether this is greater than or equal to or less than. If it is equal to, then it returns the index. If it is greater than, we will just check from here to here. If it is less than, we will check from here to here. And the same process will be repeated throughout the array, where the array is subdivided into chunks. So the time complexity of a binary search is big O of log n. So in the same way, let's solve this question also in the same direction. So what we are having, like, in the brute force approach, we solved the first element which is greater than the target is the index that we need to find. Here, what is the greater element which is greater than the target? Obviously, it's true 22. So if it's all using binary search, like, what's the thought process means? Like, we'll be dividing the array and we will we will checking whether the mid element is greater than the target. If it is greater than the target, we no need to check all these things, right? We will check from here to here. That's it. So we'll be checking from mid to target. So we will be doing e minus mid minus 1. If it is lesser than the target, that means we need to, all these things are no need to check all these things. So we'll check from above above mid element. So s is equal to mid plus 1. Here, if you see, if I run this code, 5 4 3 5 4 5. So no need to take an external index called mid. Instead, we can just use print s, like here s is the index where this entire code is stopped. And let's see the dry run of this code. Okay, let's submit. Okay, now let's take an example of an array is equal to 1 comma 2 comma 3 7 10 and 22, and the target that we need to insert is equal to 11. So as we all know that the s is here and the end is here. So if we dry run the entire code, mid is equal to 0 plus 0 1 2 3 4 5, 0 plus 5 by 2, which is 2.5 means 2. So a of 2 is greater than target. Let's check this condition. According to the code, e is equal to mid minus 1, else s is equal to mid plus 1, right? So a of 2 means 3. 3 is greater than 11, which is false. So the condition goes here, and s is equal to mid plus 1. Mid is equal to 2, 2 plus 1, 3. That means the s will be going here. Okay, now we will be checking from 7 10 22. Here s is here and e is here, and 3 4 5 indexes. So, and again we will calculate the mid is equal to 3 plus 5 by 2, which is 8 by 2, which is 4. Again we will check a of 4 is greater than target or not. What is a of 4 here? A of 4 is 10. 10 is greater than 11. No, it's not. So again it goes to the second condition, where it will be here. Yes, s is equal to mid. What is mid here? 4. 4 plus 1, 5. So this will go to the 5. So now we will be having just one element in the array with the index of 5. So again and here only we will be having e and s both. So now let's find the mid again. 5 plus 5 by 2, which is 5. A of mid is greater than target. Let's check this condition. As you all know that the condition is true since the 22 is greater than target 11. Since this is the target, and we will again move e is equal to mid minus 1. E is equal to mid minus 1. What does it mean? Mid is equal to 5, 5 minus 1. E is equal to 4 and s is equal to 5, which violates our condition, right? Like we all keep all these things in the while loop where s is less than or equal to e, where s is start and e is the end, and our condition is violated like this. So it stops and it returns the e. Okay, let's see what does stored in e and s. So if we see the last condition at mid, e is equal to mid minus 1 means e is equal to 4, s is equal to 5, right? So we will return yes here. Okay.